So, in this first question, it asks you to find the vertex and the vertex form of our problem there. So for this question, what I'd start out with is I'd start by factoring. And for right now, that is a good strategy for what skill we have. So I have y equals 5x squared minus 15x minus 20. So the next thing I do is I look at those three terms and I try to factor out maybe something common. 5. So y equals 5 x squared minus 15x minus, oh, sorry, that's not 15x, that's 3x. 15 divided by 5 is 3, and 20 divided by, or negative 20 divided by 5 would be 4. That's much better now. So in my head, I think what multiplies to 4, negative 4, and adds to negative 3, and I would think that my two factors would be negative 4 and x is positive 1. So once you get that far, you have it in factored form, and you can use this now to start finding the vertex. First thing we can do is find the x value of the vertex by finding the axis of symmetry. So I know that one of my values is 4, and I go 4 minus 1 divided by 2 to find the axis of symmetry. That's 3 over 2, and that it can be 1.5. So now what we can do, so you can take this and put this into our vertex form to find the k value. So I'd say y equals, that's a little wonky, sorry, 5. And I knew my a value was 5 because I have it here as our a value and here's our a value. So it's 5 and x minus 1.5 because that's my h value squared plus k. So the next thing we do is we then want to take a known point, and from what I understand or what I remember is we have a known point sitting right here. And that known point is the y-intercept, and we know our y-intercept would be 0, there we go, comma, negative 20. And sorry if my 2 looks wonky, I'm just near the top of the screen. There we go. So at 0, negative 20 is a known point. So we could substitute that in now to get negative 20 equals, wonky, equals 5. And that's going to be 0 for our x value minus 1.5 squared plus k. Beautiful. So we rewrite negative 20 because nothing's happened there. If I square 1.5 or negative 1.5, I get 2.5. So 0 minus 1.5 is still negative 1.5. And if I square negative 1.5, I get 5 times 2.25 plus, okay, sorry if that doesn't look like a plus sign. That's a little bit better, messy though. Negative 20 equals 5 times 2.25 is 11.25 plus k, that's a little bit better this time. I need to isolate k, so I'm going to subtract 11.25 and subtract 11.25 from both sides. And I get that k equals negative 31.25. So therefore our vertex, I'll kind of finish this out, so therefore our vertex is 1.5 comma negative 31.25. Therefore y equals, and our a value is still 5, so we've got that 5 value there. So we say y equals 5 x minus 1.5 squared minus 31.25. And there is our vertex form of the equation. So we've now converted from standard form to vertex form. So there's times where the trinomial that you're given is not going to be factorable. So for example, this one right here, you're not going to be able to factor to get the two roots. So we're going to have to use some other techniques to be able to do this. And I kind of went through a talk through, but I'm just going to start out by saying that y equals x squared minus 12x plus 5. So what we're going to do now is we're going to try to find, we're going to think about it. And if you look at this, you know that this is our one y-intercept. And in class I kind of sketched it out and said, okay, well, you know, we're going to have this, this parabola here. And our parabola is probably going to look something like this. Sorry if it's a little skewy there. And we've got one of a point there that we know, and that point right there is going to be 0, 5. And if you visualize in your head that as we go across, yikes, that just, there we go, I'll just go like that. There's going to be another point where we can think about this quadratic crossing the point, or having a point at 5. So we know that it really at some point, 5, we're going to have another point. And what we're going to try to do is we're going to use partial factoring to find this other point. And once we find that, we will find the axis of symmetry, and therefore find the vertex and find vertex form. Sorry, my pen's not perfectly lined up there, so it's a little messy. So what I'm going to do is I'm going to start by thinking in my head and say, so since c equals 5, and my c term is right here, since c equals 5, the y-intercept, this thing somehow is writing worse down, I don't know if it's me or it, the y-intercept is 0, 5, and I just kind of stated that in my drawing, but I'm just kind of writing it out. So what we're going to do in our heads is we're thinking that we need, wow, that's messy, to find the other point where y equals 5. So what we're going to do this is we are going to set y to equals 5, and we're going to find the two x values. That's a lot of writing, you don't really need to do that. I'm just kind of explaining what I'm doing. So what I'm going to do is I'm going to take my equation from right here. I'm going to set my y value to 5. So I'm going to say that 5 equals x squared minus 12x plus 5. I'm going to clean this up by getting my, taking care of my two like terms, which are my two 5's, which are here and here. So I'm going to subtract 5 from this side and subtract 5 from this side. They both cancel out to make 0. So I get 0 equals x squared minus 12x. Now I do something called partial factoring, and I think about any common factors, and both of these terms can be factored by x. So I write 0 equals x bracket x minus 12. And now I've partially factored it and I stop. So now I'm going to use these two terms and break it into two situations. I'm going to try to figure out our 2 times that y equals 5. So our first situation is we say 0 equals x, and we already knew that when y equals 5, x equals 0, so that's one of those. And then the other situation is when 0 x equal minus 12. So we'll have to add 12 to both sides. So what we get here is we get that x equals positive 12. So when I go way back up here now, and we are talking about what is that other point, the other point is 12, 5. So what I can do is I'm just going to separate some, I'm going to just kind of separate my writing off a little bit. So now, therefore, x can be 0 or 12 when y equals 5. So next we're going to do some work to try to find our vertex in our equation factored, vertex form. So we know that when y equals 5, x equals 0 plus 12 divided by 2, that's a plus, sorry if it's not clear, which equals 6 over 2, which equals to 3. So there's our one value of our vertex, or our axis of symmetry. Oops, that is totally wrong. I totally jumped ahead of myself. That's 12 divided by 2, which equals to 6. Sorry about that, guys. So now I can use this information, and I can plug it in. So I can say y equals a x minus h squared plus k. And over on this side of the screen, it just looks terrible. There we go. So now I can start plugging in stuff we know. So y equals, well, what's my a value? And we have an a value right here, and it's the number 1. We just didn't write it in. So I'm going to write it in, even though you don't need to write in your 1s. And we've got x minus 6 squared plus k. And now we need to figure out what k equals. And to do that, we can use any known point. And let's use our y-intercept still. So we can say that 5 equals 1, 0 minus 6 squared plus k. And that 5 equals, I'm going to drop my 1. What's negative 6 squared is 36 plus k. I'm going to subtract 36 from both sides. And I now know that k equals negative 31. Whew, good fit. So therefore, I'm going to kind of box some of this off. I know it's kind of crazy what I'm doing. Therefore, the vertex, wow, that's so messy. The vertex is 6, negative 31. And we know that y equals, and our a value is 1, so I'm not going to write it, x minus 6 squared minus 31. Whew, it all fit. Sorry if it's a big old mess. Alright, so I'm going to do a second example, and this time we've got a value other than 1 for our a term, so that's kind of a good one to show really quick, and it's kind of another straightforward example, and I can kind of cut to the chase a little bit more. So with this, I'm just going to take a second and rewrite it. So y equals negative 3x squared plus 15x plus 2. And on my immediate first look, there's no common term I can factor out of all three other than 1, and that's not going to help us. So since c equals 2, therefore our y-intercept is at 0, 2. So there we go. So let's find the other time that y equals 2. How are we going to do that? Well, first we're going to set our y value to 2. So we're going to set this y value right here to 2. So we'll say 2 equals negative 3x squared plus 15x plus 2. The next thing we'll do is we'll move 2 over, so we collect our like terms. These two both cancel out. 0 equals negative 3x squared plus 15x. So when I look at those two terms, what can I factor out of both of them? I hope you think to yourself that it's negative 3x, and that's going to allow our first term inside the brackets to be positive, so it'll be x minus 5 is our factor term, because what's positive 15 divided by negative 3? It's negative 5. So now we're ready to do that step where we think, okay, so what are the two times that y equals 2? So we're going to say that 0 equals negative 3x x. So 0 equals, so I'm going to divide by -3 and divide by -3. And what's 0 divided by -3? So that's 0. So that's our first time. So when x equals 0, we knew that that is going to happen anyway. So that's the one we knew right there. We knew that was going to happen. And then over here, we'll add 5 and add 5. And we'll get x equals 5. Whew, we did it. So now what we can do is we can take this information and find our axis of symmetry. So what we're going to do is we can say, therefore, y equals 2 at 0, 2 and 5, 2, which is great. So the next thing we can do is we can find our axis of symmetry. So I'll just kind of block that off. So when y equals 2, x equals 5 plus 0 divided by 2. Let's see if I can do it right this time. So 5 plus 0 is 0, and divided by 2 would be 2.5. I can now take that information and say y equals, and what's our a value? And there's 2 spots you can look to find a. You can look right here and see it's -3. Or not 2 spots, right? There's 1 spot you can look, and that's in the stand form. And that's where we can find a. So it's y equals -3, bracket, x minus, and we just figured out our h value of 2.5. And we don't know k. So what can we do to find k? I hope you're thinking to put in a known point. I'm going to put in the y-intercept. That's 2 equals -3. 0 minus 2.5 squared plus k. I can then do 2 equals -3. And what is -2.5 squared? I hope you're thinking it's 6.25 plus k. -3 times 6.25 gives us -18.75 plus k. I need to add, yikes, 18.75. And I'm going to add, oh geez, 18. It's going to be a mess. 7, 5. Sorry about this, guys. Terrible production quality. What's this amateur deal here? So it's 2 plus 18.75, and so k equals 20.75. Whew. So let's try to see if I can block some of this off. So therefore, the vertex is, and I believe our vertex is 2.5, 20.75. Alright, and then I don't have enough room to write it up here, so I'll write it down here. And so therefore, y equals -3. Oh boy, this is going to be a tight fit. X minus 2.5 squared plus, yikes, 20.75. Sorry, 20.75, and that went right up in there. I can't even write it. I don't have that much room. There we go. Sorry about that, but there we go. That's a quick summary of how to use partial factoring to go from standard form to vertex form.